Unit 9, Day 3. How do you find the area of sections of a circle? That's your essential question for today. How do you find the area of sections of a circle? Okay, so take a look at these different sections of the circle. All right, we have a sector of a circle. This is called a sector. The sector is, if you notice, it's kind of like a slice of pizza. That's the way I always look at it, or a slice of pie, whatever. So we've got our slice here. Notice that where the two sides meet, it makes that central point, okay, that center point of the circle. That is the sector of a circle. We then have a segment of a circle, and notice what happens with the segment of a circle. If you want to check out down here, sector and segment, the segment is the region between a chord and the arc of a circle. So notice we have a chord here, and remember a chord, it can go through the center, okay, but that would be called a diameter. So the segment of a circle with the chord is anything that touches, the chord touches the two outside parts of a circle, okay? And then that's made with the arc, so it's that section there. And then finally we have the annulus, which I think of kind of like a donut, all right? So we've got our annulus here. And what we need to do is we still are finding the area of the shaded region or the shaded part. So our annulus is this shaded part right here. So it's like a donut or a tire or even kind of like a dartboard. You can look at it that way also. Each one of these has a separate area formula, okay? So the area of a sector, make sure you get those drawn. We have our area of our sector. What the sector is going to be, first of all, notice what we have. We have a whole circle. So somewhere in that circle or that area formula, you can guarantee that we're going to have the formula for a circle, which is pi r squared. But we only want this part. So what we're going to do is we're going to take whatever this angle is, we're going to call it A. So please label that A. And it's a little a. Now that A, don't get that confused with what we did last time with the apothem. This is just A as in our angle. So it would be little a over, well, we want the part of the whole. Well, the whole of the circle, when we're talking about angles and degrees, the whole is 360. So our area of our sector is A over 360 times pi r squared. The segment, again, we're going to take, this time, if you notice, with the segment, okay, it kind of makes a triangle here. And so when we do that, notice we make a sector. The whole thing, when we include our radii there, we make a sector, okay? So we're going to start off with that formula, A equals 360 times pi r squared. But notice what we subtract out. What's that shape of that part right there? Well, it's the shape of a triangle. So what we have to do is we have to subtract out a triangle. Well, the area of a triangle is 1/2 base times height. So that's our area of our segment. And then notice what our annulus is. The area of an annulus, okay? Our annulus, we have the big circle, and we want to cut out the small circle. Well, each circle, they share the same center. So this would be our little r, and then we have a big R. So the radius, I made a little r for the radius of our little circle, and big R for the radius of our big circle. So what we have to do is we have to take the area of our big circle, which again is pi r squared, but I'm going to use that big R, minus the area of our smaller circle, which is little r squared. Both of them are still using the same formula, but you've used the different radii in order to plug in. Big R is for the big circle, little r is for the little circle. Remember this word concentric. They share the same center, concentric. Okay? So hopefully you have those written down. If you need to pause, go ahead and do so. Let's start doing some examples. Now, they say, okay, we have our sector. All right, so let's start off. Remember, you got to write down the formula. A over 360 pi r squared. Fill in what we know. Well, we're looking for area. Our A is our angle, which is 45 degrees over 360, times pi, times our radius is 20 squared. Again, it depends on whether they ask for exact or they ask for approximate, whether or not you plug that pi in. Let's just go ahead and do the exact answer right now. So, first I'm going to take 20 squared, which is 400. Okay, and then I've got pi. I'm going to go ahead and move the pi to the end. And then 45 over 360 is 0.125. All right, so I'm going to multiply those two together. So 0.125 times 400. And I get 50. All right, so we've got 50, and then I have that pi. We're dealing with centimeters, so it would be centimeters squared. Okay, so if they ask me for the exact answer, all I would have to, that is the exact answer. If they ask me for the approximate, remember all I need is I need to change this to approximately here. I take 50 times 3.14. So 50 times 3.14, and we get area is approximately 157. 157 centimeters squared. Now the reason why, now this looks kind of funny because we don't have a decimal here, but the reason why we still have to keep that approximately sign there is because we still use 3.14 instead of 3.14159, blah, 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 okay? So that's what we had to do to keep that approximate sign. So either answer works, it's just whatever they ask you for. Again, all we're doing is plugging in. Again, what you're going to have to do to get full credit on a test, put this +1, plug it in +1, and give me your answer and your unit. That'll give you 4 points on the test or the quiz. Okay, let's try another one. All right, so find the area of the shaded segment. Okay, so we know the segment formula is A over 360 pi r squared minus 1/2 base times height, because notice we're taking out a triangle. All right, so let's fill in what we know. Well, I've got a 90-degree angle there. I've got the radius is 6. All right, now look at the triangle. My base is 6. Well, notice this is our radius. Well, what's this? Isn't that also our radius? So if that's 6, this is also 6. So I put in 6 times 6. That's the distance from the center to the outside. That's the distance from the center to the outside. We know those are the same. Okay, so let's go ahead and work some of this out. 90 over 360 would simplify to 0.25. 6 squared is 36. I'm going to go ahead and put that there, and then keep the pi. I like to just move that to the end. Minus 1/2 of 6 times 6. Well, that's 36. Half of that's 18. Okay. So now I need to take 0.25 times 36. So a quarter of 36, or a fourth of 36, is 9. So this is 9 pi minus 18. It was centimeters squared. This is my exact answer. Okay, I can't subtract 9 minus 18 because that pi is kind of like an x. Okay, so we can't subtract that out because that doesn't work, because pi is the number that we need to plug in. Okay, or you can do it the approximately way, which means I'm going to put 9 times 3.14 minus 18. And in that case, we get 10.26 centimeters squared, if you go ahead and work that all out, but it's approximately. Again, that's exact because we didn't plug pi into the calculator. All right. Okay, next we have You got to determine what you're looking at, and we're looking at a sector. So we're going to use the area formula for a sector. Now, this time, though, they tell us what the area is, so we're going to plug in what we know. 14 pi equals, okay, we don't know what x is, which is our angle. Pi, we know the radius is 6 squared. So we have 14 pi, and then we have pi times 36. All right, what we're going to do is we're going to divide both sides by 36 pi. The pi's cancel out. Okay, so 14 divided by 36 is 0.3888, and so on. I'm going to keep that. If you notice, I have that, if you can see it there. I have that in my calculator, and I'm going to keep that in my calculator. So I'm not going to clear my calculator. But now what I have left on the other side is x over 360. So in order to solve for x, we're dividing by 360, so we need to multiply by 360. So again, I didn't clear that from my calculator. I'm going to times that by 360, and I get 140. I get a nice, even degree. And it is equals, I was looking for the angle, right? And it is equals because I kept that in my calculator and I didn't round it. And that way it turned out to be a nice angle of 140 degrees. So again, nothing different than what we were doing before. We're just plugging in for each variable that we already know. Okay? Here we have an annulus. Okay? It's kind of blurry there. Hopefully you can see it okay. Let's write out the formula. Pi big R squared minus pi little r squared. Let's fill in what we know. Well, if we know this whole distance across here is 10, what's the radius of our big circle? Well, we know that the radius is half, so that means that's 5. So it would be pi 5 squared minus pi, the small radius is 2 squared. So area is 5 squared is 25 pi minus 4 pi. Now, this time, because they both have pi on them, we can subtract. So 25 pi minus 4 pi is 21 pi, and it's centimeters squared. That's area. Or if we want to do approximately, that's where we just plug in 21 times 3.14, and so we get 65.94 centimeters squared. The approximately gives us kind of a better idea of what we're talking about. So we're talking about 65.9 centimeters squared instead of 21 pi, because it's kind of hard to visualize 21 pi. All right. Next example. Just got a couple more examples here for us to do. Okay, here. Notice we have a segment here, but it's the segment that we're taking out. So we want the area of the shaded part. So basically what we want to do is we want to take the area of the circle. What I'm doing here is I'm using the big A, and then I'm putting the circle there. That's just kind of a label. And I want to subtract out the area of the segment. And that's going to give me the area of the whole circle, or the part that's shaded, the shaded part. So let's start by knowing what the area of our circle is. Well, area equals pi r squared. So I'm going to fill in all of that. Area equals pi. 8 is our radius squared. And I'm going to go ahead and leave it an exact answer for right now. So 64 pi. Okay, now the area of our segment. Remember that is A over 360 pi r squared minus 1/2 base times height. That's the area of our segment. So let's figure out what we have here. We know it's a 90-degree angle. It's right there, 90 degrees over 360. Pi, our radius we know is 8 squared. So if that's 8, that's 8 minus 1/2, 8 times 8, because those are the sides. So area equals 90 over 4, again, that's 0.2, or 90 over 360 is 0.25. Times 64 pi, I'm just going to move that there, minus 1/2, 8 times 8 is 64, half of 64 is 32. So we've got A equals 0.25 times 64 is 16 pi minus 32. Now, that's the area of our segment. Now, what do we have to do with both of those is subtract. So what's 64 pi minus 16 pi minus 32? 64 pi minus 16 pi is 48 pi minus 32. That's our exact answer, centimeters squared. Or we can plug in 48 times 3.14 minus 32, and we get area is approximately 118.72 centimeters squared. Again, it just depends on what they ask for. Okay. All right, now we're looking for the shaded area, or we know the shaded area of this annulus. So again, it's pi big R squared minus pi little r squared. Got to use that formula. Fill in what you know. We know it's 32 pi. Pi, okay, 18's all the way across. So that means that the big R is actually going to be 9 squared minus pi r squared. We don't know, that's what we're looking for, is the little r. Okay, so we've got 32 pi equals, that would be 81 pi minus pi r squared. So let's go ahead and think of those pi's like they're x's. So what I'm going to do is I'm going to move this over, so minus 81 pi. We're just going to solve. We're going to solve for that r. 32 minus 81 is negative 49 pi, and that equals negative pi r squared. I'm going to divide by the negative and the pi. Remember, pi is just a number. So that cancels that out. And the negative divided by negative is a positive. And now take the square root, and our radius is 7. So we know that the little r is 7 centimeters. And that was just solving. Plugging it in using algebra. Okay? Now we have our annulus, but look at what's taken out. Do you guys see there's a sector there? Okay? We'll talk more about that in a second. Let's figure out what the whole area would be if the annulus was complete. Okay, this reminds me, I had stuffed crust pizza from Pizza Hut, and so this kind of reminds me of that, okay, here's our stuffed crust. How much area does the stuffed crust part take up of the whole pizza? And then I had a piece of it, okay? So we've got to figure out, well, how much did I take out when I took my piece of stuffed crust pizza? How much is taken out, all right? So let's start off by figuring out the radius of the whole annulus. The area of the whole annulus. So, again, pi big R squared minus pi little r squared. They told us up there what everything was, so that'd be 12 squared minus pi 9 squared. So that would be 12 squared is 144 pi minus 81 pi. Because they both have pi, we can subtract it. So 144 minus 81 is 63 pi. So that means that the area of the annulus is 63 pi. Now, I have 60 degrees taken out of it. Okay, so I can do this a couple different ways. The way I'm going to look at it is that since there's 60 degrees taken out of the whole, what is 60 degrees out of 360? Well, isn't that 1/6 of the pizza? Or 1/6 of the annulus, 1/6 of whatever the circle is, right? So what I'm going to do is I'm going to take 1/6 of that 63. So to take 1/6 of something, I would just multiply by 1/6. So 63 times 1 divided by 6, or 1/6, and we get 10.5 pi. Keep that pi. So 1/6 of 63 is 10.5, and then we keep that pi, centimeters squared. So all I did was I figured, okay, that's 60 degrees. I found the area of the whole annulus. I've got a sixth of it taken out because 60 out of 360 is 1/6. And then since I took 1/6 of the 63, I got 10.5 pi. All right, that was our last example. So what you need to do now is, if you need to go back and look at any examples again, go ahead and do so.